Okay, today we're working on the substitution method, which is a way of solving systems of equations instead of graphing them. Because graphing is far too much work when you can make it a lot easier by using substitution or elimination, which will be my next video. Alright, so we're going to start off with a few examples. First thing we have to do is get x or y by itself. Now sometimes that's already given to us. For our first example, that's what the case is. So we have y equals 4x plus 3. So what we do is we know y equals 4x plus 3. So we're going to take that and we're going to put it for this y here. So we take this and we substitute that into the y here, which is going to give us an equation of all x's. So it's actually solvable after you do that. So we take 4x plus 3, it goes in there. Everything else in this equation stays the same. So we get 2x plus 4x plus 3 equals 9. And since there's nothing to multiply here, we don't really need these parentheses. So those can just go away. And then we just add like terms and solve it like normal. Here we have 2x plus 4x is 6x. And then we could minus 3 from both sides. That's going to give us equals 6. 6x equals 6. And then last step, we would divide by 6 on both sides. So x equals 1. Now we take that and plug it into whichever equation is easier, and that'll give us our y value for our final answer, our coordinate point, which is what we're looking for. So we take x equals 1, plug it into the easier one, which looks like this, because y is pretty much already solved for here. We have y equals 4x plus 3, and we're plugging in x equals 1. So y equals 4 times 1 plus 3. So we get 4 plus 3, y equals 7. And from there we know our coordinate point because our coordinate point is x comma y. So the answer would be 1 comma 7. For number 2, not quite as easy because they don't just give us x or y. So what we have to do is look for something that's easily solvable for. So here, x is by itself already. Since x is by itself, that's going to be the easiest thing to solve for. Everything else we would have to do a bunch more work for. So let's call this equation 1. And we're going to take it and solve for x, since x is already almost by itself. So take equation 1, 3y minus x equals negative 6. And what we can do is we can move the x over this side and move this 6 over this side. So x is solved for. So we can add x, both sides, 3y equals x minus 6. And then we can add 6 to get x by itself. Okay, so we have 3y plus 6 equals x. And then we're going to take that and then we're going to plug it into equation 2. So whatever equation you solve for, that has to be plugged into the other equation. If you plug it into itself, it's not going to work out. So we take this, our equation 1, and we plug it into equation 2. So we know x equals 3y plus 6. So that is what that x is going to become. So we have negative 2 times 3y plus 6 minus 3y equals 15. Now we distribute. That becomes negative 6y, because negative 2 times 3y is negative 6y. Negative 2 times positive 6 is negative 12, so minus 12 minus 3y equals 15. Add like terms, and at the same time we can move the 12 to the other side. Those are like terms because they both have y's. Negative 6 minus 3 is negative 9y. And we will add 12 to both sides. So that's going to give us 15 plus 12 is 27. negative 9y equals 27. From there, we would divide by negative 9, so y equals negative 3. Now we just need to find x. And the easiest equation to use is actually the one that you solved for right here. We know x equals 3y plus 6. So, x equals 3y plus 6. Just plug in negative 3 into our y. So x equals 3 times negative 3 plus 6 is negative 9 plus 6. So x equals negative 3. Again. And that would give us a coordinate point x comma y. So our answer would be negative 3 comma negative 3. Alright, last one, same process. First we have to solve for x or y. And like the last one, x is going to be the easiest thing to solve for because it's already almost by itself. We have negative x, and everything else has something in front of it. So let's take our equation, and we can call this equation 1 and equation 2. Let's take equation 2 and solve for x. Negative x minus 3 over 2, y equals negative 2. If we're solving for x, we can move our y term over by adding 3 over 2y to both sides. So we get negative x equals 3 over 2y minus 2. To get rid of the negative, you could divide by negative 1, but essentially you're just flipping all the signs. So we know x equals 3 over 2, negative 3 over 2y, plus 2. And then we could take that, since it was equation 2, and plug that into equation 1. So let's go ahead and do that. So we're going to plug 2 into equation 1. And we know that x is negative 3 over 2y plus 2. So we're going to take that, and we're going to plug it into the x in equation 1. So we have 2 times negative 3 over 2y plus 2. We're going to have to distribute there. Plus 3y equals 4. When we distribute, we get 2 times negative 3 over 2. The 2's cancel out. 2 divided by 2 is 1, times 3 is 3. So we get negative 3y. 2 times 2 is 4, plus 4. Plus 3y equals 4. Okay, well something weird happens there. We have negative 3y plus 3y. Those are our like terms. If we combine those, they go away. And this happens sometimes in substitution and elimination. We ended up getting 4 equals 4. And we know that's always the case. 4 always equals 4. So what happened here is we got infinite solutions. Whenever you get a number equaling itself when you're doing something like this, infinite solutions. If you get, say, if you get 0 equals some number like 5, when you're doing substitution or elimination, that's no solution. Because 0 never equals 5. And that'll be it for today. Thank you.